So for your warm-up, we're going to graph these two functions. X squared is what type of function? It's a quadratic. So it should be a parabola. Where we talked about this yesterday. Square root of x is the inverse of that. So if we want to graph it, we're just going to make a t-table like we did yesterday. Right, this is f of x equals x squared. So just plug in some x's, get some y's. This one doesn't have any restrictions because we're just squaring. So I'm going to plug in some negatives and positives. So I'm going to do -2, -1, 0, 1, and 2.
Tommy, you'd be proud. I'm into
this. Okay, so we're just going to plug these in, so we're just squaring them. So we're going to do -2 squared, which is 4. -1 squared, which is 1. 0 squared, 0. 1 squared is 1. 2 squared is 4. So we're going to go ahead and graph.
On the web.
Oh. We're going to go ahead and graph. So it should be 0, 0, -1, 1, 1, 1, and then we're up at -2, 4, and 2, 4. Also, alright, so let's do g of x now. So we're going to plug in some nice numbers that we can square root. What were the numbers that we plugged in for x? 0. What was next? 1. Then what? 4. And then 9. Alright, so square rooting those, we'll get 0, 1, 2, and 3. So if you graph, it'll be 0, 0, 1, 1, 4, 2, 9, 3. Alright, so just to get us thinking about our radicals. So today we're going to mainly focus on the key features of our radicals. Alright, so they give us this function, this is a square root function. They give us a table. We're going to go through and find all the key features. Before we do that, just to kind of refresh, if I have a +4 underneath the radical, where is it going to go? To the left. Yep. So remember opposite. So we're doing left. That +4 would get us a left 4. And then the -1 on the outside would do what? It's going to go down 1. So that would be a vertical transformation if it's on the outside of the radical. We're not really going to talk about like what happens with the number in the front for the purposes of this class. All right, so let's go through our table and graph. So we're at -4, -1, -3, +1, 0, +3, and 5, +5. Alright, so for domain, is domain my x's or my y values? X's or y's? It's the x values. So for domain, we scan from left to right. That's how we figure out our domain. We've talked about it a few times before. We want to look and see, like, where do I start getting x values? Where do I stop getting x values? So if we're looking from the left of the graph, and we look, where does my graph start? What x value? -4, right? At first point, that first order pair on this graph starts at -4. So this domain is going to start at -4. Now we actually have an ordered pair there, so we do include it in our domain. So if we include it, we're writing these in interval notation. Do we put a bracket or a parentheses around it? Bracket. So if it's actually included, we put a bracket around it. All right, so looking to the right, does that graph ever stop? No, so your x's will keep getting bigger and bigger and bigger forever to infinity. So we're going to say the domain would be going off to infinity. And what do we always put around our infinities? Parentheses. All right, so range, that's the y values. So this is when we scan from the bottom of the graph to the top of the graph. All right, so let's start. We're going to scan from bottom. What y value do I start at? -1. Yep, that bottommost point starts at -1. We actually have an ordered pair there on our graph, so are we going to include it? Is it going to be a bracket or a parentheses? It'll be a bracket. We do include it, so we're going to put bracket. All right, and then above that, does the graph ever stop? So looking above -1, does the graph stop? No. So what's the y value going to do? It'll go to positive infinity. So they're going to keep getting bigger forever. So we have a positive infinity. All right, so x-intercept and our y-intercept. X-intercept is where the graph crosses the x-axis. What's the y value at our x-intercept?
Is it 3?
In general, it's 0. So it's always like x comma 0. It's what's the x value when y is 0. And then it's the opposite for the y-intercept. What's the y value when x is 0? So for this one, we can easily see the y-intercept on this one. They give it to us in the table. We can see it on the graph. What is it? It's 3. Yeah, it's this 0, 3. Always write them as an order pair. So it'll be 0, 3. For your x-intercept, it looks kind of like it's crossing at like between like -3 and -4. It's like a decimal. So we're actually going to go ahead and like solve it and get the right number. So we want the x value when y is 0. So we're going to set our equation equal to 0 and solve and get what x is. So we're going to take this g of x. We're going to set it equal to 0. So we're doing 0 equals 2 square root of x plus 4 minus 1. We're going to solve and see what x is when y is 0. So this is a radical equation. So someone remind me what I need to do when I'm trying to solve my radical equations. Yeah, we're going to isolate the radical. So we're going to first get rid of that -1. So we're going to add 1 to both sides. So we get 1 equals 2 square root of x plus 4. Now you can divide both sides by 2 and then square both sides, or you can square it like it is. Doesn't matter which you do. I'm going to go ahead and square it like it is right now to get rid of that square root. So on the left side, I'll have 1 squared, which is 1. And then on the right side, I got a square of the 2, so I get 4. And then the square root cancels out with the square, and I'm just left with x plus 4. All right, so to go ahead and start solving, what do we need to do?
Disregard.
distribute. Now we're going to distribute that 4, so we do 4 times x, 4x, 4 times 4, which is 16. Now what should I do? Minus the 16. So I get negative 15 equals 4x. And then lastly, we would divide both sides by 4. So x equals, and we're just going to leave that as a fraction, negative 15 over 4. So your x-intercept is negative 15 over 4, comma 0. So increasing and decreasing, remember this is where increasing is where our graph is going up, increasing is where our graph is going down. So for these, I told you to like imagine a person walking on your graph. So if I got a little guy walking on my graph, right off the bat, what is he doing? He's increasing, right? He's walking up, like he's kind of walking up a hill. Does he, if that graph keeps going, does he ever go down? That graph is going to keep going on, keep going up forever and ever. So there's not going to be any decreasing for this graph. So we're going to say none. Right? He's going to be walking up that graph forever. So we always want to use our x values when we're writing these intervals. Like at what point, what x values is he going up or the y values going up? So he starts increasing where the graph starts. So what x value does the graph start at? Negative 4. So we're going to start it increasing at negative 4. Now he starts going up right off the bat, so we are going to include it and put a bracket around it. And then he never stops going down, so he's going to increase forever and ever. So he's going to increase to a positive infinity. Alrighty. Positive and negative intervals. Who remembers what these are? Does anyone remember? Brandon, what you think?
When the graph or the function is above or below the y or x-axis?
Yeah, so Brandon says when it's above or below the x-axis. So positive would be when it's above the x-axis. Negative would be when it's below the x-axis. So this one we want above the x-axis, and for the negative we want below the x-axis. So for your positive interval, so we want anything above the x-axis. So we start being above when it crosses the x-axis. So at that x-intercept, everything above, everything after that, that's where my graph is above. Right, so we start at that negative 15 over 4. Right, this little chunk right here, that's what's below. So if we start at negative 15 over 4, and we want to think about what are the y values doing. So what's the y value at the x-intercept? 0. Is 0 positive? No, it's not positive, it's not negative. So we don't include it in the interval. So we would put a parentheses around it. So because we're at 0, 0 is neither positive nor negative, so we always put parentheses if we're talking about those positive and negative intervals. And then after that, the graph is positive forever and ever, so it's going to go off to positive infinity.
Is it okay if you write 3.75 or negative 3.75?
That's fine. All right, so negative, like I said, negative, the negative interval is that little chunk right here before the x-intercept. So the graph, what x value does the graph start at? -4. Are we going to include that -4 in our negative interval? Yeah, that -4 has a y value of -1, so we can include it. So we're going to put a bracket around it. It is negative, it's below the x-axis. And then we stop being negative at what number? Yeah, the -15/4. So when we started being positive, that's where we stopped being negative. Are we going to include that -15/4? No, it's 0 at that point, so we don't want to include it, so we want parentheses around it. Right. For your minimum and maximum, max is like a relatively high point of the graph. Minimum is like a relatively low point on the graph. So this graph goes up forever and ever. Like it never stops going up. It's always increasing. So there's not going to be like a maximum point of this graph, because if it's always going up, there's never going to be a point where we like reach a high point. So for this one, we're going to have a minimum, and it's going to be at that point where we started the graph. Right? That's like the low point of this graph, and then it starts going up. So we're going to say this one has a minimum, and it's at that starting point, so that -4, -1. All right. Lastly, the end behavior. So the end behavior, that's how the ends of the graph are behaving. So we want to look at the left end and the right end. So for this, we're going to use our domain. So we're going to use this -4 and this positive infinity. So we're going to look at what's happening as the x's go off to positive infinity. So that's like the right half of the graph. What are the y values doing? We want to figure out what the y's are doing. And then we also want to figure out what's happening to the left half of the graph. And the left half of the graph is going up until -4. So as x is going to that -4, what are the y values doing? So we're going to use both ends of our domain to help us with this. So looking on your right side of your graph, as x gets bigger and bigger, so look to the right, what are the y values doing? They're getting bigger, right? That graph's going up. So they're going to positive infinity as well. So the y values keep going up forever. Right? Left half of the graph stops at -4. So what y value is it stopping at? -1. So the y is going to -1 for the left half of the graph. Alright, so we're going to go through this one a little bit faster. So for this one, they don't give us a table. So we're going to try to figure out what x's we want to plug in for this. If we are subtracting 3 underneath the radical, what's that going to do to my graph? It's going to go to the right 3. So we're going to do what to the x values? Add 3. So we always do the opposite of what we think it should be. So your original x values we plug into our square root are 0, 1, 4, and 9. And this one has one more. What's the next number after 9 that I could square it nicely? 16. So we want to add 3 to all of those. So we're going to plug in 3. 1 plus 3 is 4, 7, 12, and then 19. In the interest of time, we're not going to go through all of these because like on your homework, I'm just going to give you the graph and ask you to do your key features. So if you plug these in, you should get 3, 2, 1, 0, and -1. All right, so go ahead and graph this on your thing. So we're at 3, 3, 4, 2, 7, 1, 12, 0, and then 19, -1. All right, let's go through our key features. So domain, x values, we were going to scan from the left to the right. What x value do I start at? 3. Yep, we started plugging in 3. That's where my graph starts. Am I going to put a bracket or a parentheses around 3? Bracket, yeah, we got an ordered pair there. We included it. So we're going to put a bracket. After 3, does my graph ever stop? Nope. So what should I put next? What are my x's doing? Yeah, they're going to get bigger forever. So on the right side, those x's get bigger and bigger. So we go to positive infinity. And we always put our parentheses around our positive infinity. All right, for the range, that's my y values. So we want to look from the bottom of the graph to the top of the graph. So we're looking at this one, looking upwards. The y values are coming from where? Negative infinity, right? We have all of these negative y values. Up until what number do we stop getting y values? What's the topmost point of that graph? 3. So it's 3, 3. So above that 3, I don't have any more y values. All right, my graph stops. I don't get any more graph above there. All right, so we always put parentheses around our infinities. And then are we going to include that 3? We're going to put a bracket or a parentheses around it? Bracket, yeah, we got an ordered pair there, so we are going to put a bracket around that one. All right, so x-intercept, that's where y is 0. Y-intercept, that's where x is 0. All right, both of these, we don't have to actually solve either of these. X-intercept, they give it to us. It's in the table. It's on the graph. What is it? It's a 12, 0. All right, y-intercept, does that graph have a y-intercept? But it won't, it's not going to cross the y-axis. Oops. Because like 0 isn't included in our domain, right? 0, that's when x is 0, that's our y-intercept, and our domain starts at 3. So we can't ever have a y-intercept for this one. So there is none. All right, increasing, decreasing interval. Increasing is where the graph's going up, decreasing is where the graph's going down. So think about a person walking on your graph. All right, what's he doing right off the bat? He's decreasing. Will he ever increase? Oh, he's going to walk down that graph forever. So we're going to say there's no increasing intervals. So for the decreasing, he's always going down. So we're going to basically use our domain. So he starts decreasing right at when the graph starts. So when x is 3. And we're going to include that because he starts going down right off the bat. And then he keeps decreasing forever and ever. So our x's are going to positive infinity. And always put parentheses around your infinities. It's positive infinity because the x's are going to positive infinity. So when we write our decreasing intervals, we always write it in terms of our x values. So where decreasing is like when the y's are going down, so like he's going down the graph, what are the x values doing? So he starts decreasing right when the graph starts at x equals 3, and then because the x values are getting bigger, that's why it's positive infinity. Good question. Other questions? All right. So positive and negative intervals. Positive is where our graph is above the x-axis. Negative is where the graph is below the x-axis. So for positive, someone tell me what they think for this one. Where's my graph above? Caroline, what do you think? 3 to 12? All right, so when x is 3, yep, we're up here up until 12. Yep, 12 is where like that we cross and we start going underneath. So from 3 to 12, so we'll always use our x values because we're thinking what are my x values when my y's are positive. So from 3 to 12, that's that portion of the graph when it's above. Am I going to put a bracket or a parentheses around 3? Bracket, yep. It's above, way above the x-axis. We're going to include it. It's a horrible bracket. Here we go. 12, am I going to put a bracket or a parentheses? What's your y value at 12? 0. So we want to think, is 0 positive or negative? It's neither. So we're going to put a parentheses around it. So then for our negative interval, who has an idea what our negative interval would be? Where are my y values negative? Where do they start? Going below the x-axis. At 12? Yep. So when we cross, again, y is 0 at 12, so we're going to put parentheses around it. And then, what after that? Does the graph ever go above the x-axis again? No, it's always going to be negative. So the x values are going to positive infinity. So the y values are below, but the x values are getting bigger, so we're going to say positive infinity. All right, for this one, do we think it's going to have a max or a min? Max or min? I would say, yeah, max, because there's like a high point on this graph. It's after that, it just goes downwards. So that high point where that graph starts, that's going to be our max. That's at 3,3. All right, and then for the end behavior, we're going to use the two ends of the graph. So just like from the last one, our two ends of our domain, so the positive infinity and the 3. So as x goes to positive infinity, we want to figure out what the y's are doing. And then as x goes to 3, we want to figure out what the y's are doing. So for positive infinity, that's when we look at the right side. So as x gets bigger and bigger, what are the y's doing? They're decreasing? So they're getting smaller? So they're going to negative infinity. Yep, so that graph's going down, those y's are getting negative, so they're going to negative infinity. Okay. Looking at the left half of the graph, so as we get closer to 3, what number are the y values going to? They're getting closer to what number? What's the y value at 3? 3. So they're getting closer to 3. They're approaching that first point of the graph. All right, so we did 2 square roots, and now we're going to talk about cube root 1. They give you x's already for this one. And again, I'm not going to make you plug these in, so I'm going to tell you what numbers you get when you plug them in. You would get -5, -3, -1, 0, and 1. We're going to go ahead and plot this and draw our graph. So we're at -2, -5, -1, -3, 0, -1, 2.3750, so like a little bit past 2 on our x-axis, and then 7 up at 1. All right, so for this one, the domain and range, like if we're scanning from the left and right and like up and down, the graph, this one goes on forever and ever, right? The square root ones we saw, like they stop at they start at a certain point, but both ends of these graphs go on forever and ever. So we can have any x's, any y values, anything for these. So for domain and range, both ends are going on forever and ever. So we say that the domain and range is negative infinity to positive infinity. And that's both for the domain and the range, and that's for all of your cube roots. They won't have any restrictions on your domain or range because like both ends go on forever. You can plug in any x's, get any y's. So that will be the domain and range for all of your cube root functions. All right, so x-intercept, again, that's x when y is 0. Y-intercept, that's y when x is 0. This one, they give both of these to us. What's the x-intercept on this one? 2.375. Yep, if we look at our table, y is 0 at 2.375. Right, your answer is an ordered pair. And then they also give us the y-intercept. What's the y-intercept of this one? 0, -1. Good, right here. X is 0, y is -1. All right, so increasing, decreasing. Again, we want to imagine a person walking on our graph. So when he's walking, what's he doing? He's increasing. So he's like walking up this hill. Does E ever go down? Nope. So we're not going to have a decreasing for this one. Right, this graph will continue to get bigger. The bigger numbers we plug in, the bigger the y values will get. So he's always increasing. So what do we think it would be like the interval? Negative infinity to positive infinity, right? Those x's forever and ever, both ways, he's always going to be walking up. So he's increasing from negative infinity to positive infinity. All right, positive and negative intervals. Again, positive is where we're above the x-axis, negative is where we're below. Who has an idea for our positive interval? Where's that graph above the x-axis? 2.375. Yep, right when we cross right here at that x-intercept, that's where my graph starts being above. So we're going to start at that 2.375. Does it ever go below the x-axis after that? Nope, it's going to keep getting bigger, so the x's are going off to positive infinity. And then we always put parentheses around our infinities. Are we going to put a bracket or a parentheses around the 2.375? Parentheses. Why parentheses, Grayson?
Because it's on the 0.
Right, because it's on the x-axis, so y is 0, and 0 is neither positive nor negative, so we put parentheses. And it's kind of safe to say if you're doing these positive and negative intervals, you're usually going to use parentheses. All right, so negative interval, we stop being negative once we start being positive. So we're going to stop this interval at that 2.375. Right, this lower half of the graph, that's where we're negative. So up until that 2.375, that's where we're negative. And we're going to put parentheses around it. So I'm coming from, and we're talking about our x values, over here, the x values are coming from negative infinity. Right, up until that 2.375, I got all these negative x's, and then we stop being negative. All right, lastly, for our in behavior, we're using the domain again, but the domain this time is positive infinity and negative infinity. So we're still using the right half of the graph and the left half of the graph. They already wrote it out for us. So as x goes to positive infinity, so we're looking to the right, x is getting bigger. What are the y's doing? As the x's get bigger, what are the y's doing? They're getting bigger. So they're going to positive infinity as well. Right, that graph keeps going up. And then for the negative infinity, we're going to look to the left. So as the x's get smaller, what are the y's doing? So we're looking to the left. What's happening to the y values? They're decreasing. They're getting smaller. So they're going to negative infinity as well. All right. So we're going to just quickly talk about this one. I'm going to plot a few of these. I'm going to do like these middle few. So -2, 7. -3, 6. -4, 5. I'm going to go 5 up to 8. Something like that. So part A says, are there any domain or range restrictions for the function? So what did I tell you about the domain or range for our cube roots? It was the same every time. What is it? Yeah, negative infinity to positive infinity, right? Because both ends of the graph go on forever. So are there any restrictions for our domain or range? Nope. So for your cube roots, it's always going to be negative infinity to positive infinity. We won't ever restrict those. For this one, for your increasing, think about your person. What's he doing right off the bat? He's increasing. Is he ever going to decrease? Nope. So there's no decreasing, so part C. And if he's always increasing, what's my interval going to be? Negative infinity to positive infinity. All the time. Right. And then lastly, for our in behavior, we want to look as x goes to positive infinity and as x goes to negative infinity. We want to figure out what the y's are doing. So as x gets bigger and bigger on the right, what are your y's doing? Are they getting bigger or smaller? They're getting bigger. So the y's are going up, so those are going to positive infinity. And as x gets smaller and smaller, what are the y's doing? They're decreasing, so they're going to negative infinity. Good.